Hello and welcome to this run-through of our 6-mark buffers question we set recently for homework. I just want to quickly go through some tips you might want to consider when you come across level questions like this. So first of all, if you come across a level question in an exam, you can always tell this because it'll have a star next to it. So you should use the body of the question to work out how to structure your answer into subheadings. So by doing this, you'll be able to address all the parts of the question systematically without leaving something out by accident. So let's look at the buffers question that was set. So let's look at what the question is asking first of all. It says, a research chemist wanted to make a buffer system with a pH of 5 and a total volume of 100 centimeters cubed. So what that part of the first sentence means is that the volume that you're given, 100 centimeters cubed, should lead to pH equals 5 with a suitable concentration of hydrogen ions. So where it says describe how the chemist could make the buffer solution, that part says to me that some kind of procedure description is needed as to how you would make it up, what would you add to what. So where it says starting from only solid pellets of ethanoic acid and sodium ethanoate, that would say also that solid pellets would mean a mass needs to be calculated for each of those two chemicals, ethanoic acid and sodium ethanoate. So now what this means is, now we've read the question, we can make a plan. So that means our plan can be split into two sections, can't it? Calculation of masses and practical procedure. So the data you're given is the Ka, and you've got the pH, so you can get the hydrogen ion concentration by doing 10 to the minus pH. But 10 to the minus pH will give a value in moles per decimeter to the minus 3, which is the standard unit of concentration. So for 100 centimeters cubed, this is 10 times less. So in our practical procedure, if you add the calculated masses of solid to the same volumetric flask, you can make it up to the 100 centimeters cubed mark, so that means that in your answer you've got to say that the volumetric flask has to be 100 centimeters cubed. So now what we can do is we can structure our answer according to what we've now planned. So now we've planned it out, we can start looking at it with fresh eyes. So I've cleared all the annotations away to make it nice and easy to start. So I'm going to split my page into two sections. So I've got my calculating masses section and my practical procedure section. So let's start with the calculating of masses. So if I start with my Ka expression, I can now put in some numbers that I'm given in the question. So I've identified them. So if I insert those numbers in, so with a little bit of rearrangement we end up with the buffer ratio. So H plus we know, Ka we know, so we can put those numbers in. So that shows us that those are the equivalent concentrations. So if we divide one number by the other, we can get the ratio. So we can use mass equals moles times mR, but that would give us the value for 1,000 centimeters cubed. So in 100 centimeters cubed there must be 1/10 of the moles that are present. So for the mass present for each substance in 100 centimeters cubed, you do moles times mR divided by 10. So applying that idea to our two substances, ethanoic acid and sodium ethanoate, that means we need those two amounts in 100 centimeters cubed to make a buffer that has a pH of 5. So the practical procedure is all that's left. So you weigh out separately 3.33 grams of ethanoic acid and 8.2 grams of sodium ethanoate. So you add those together to a 100 centimeter cube flask, volumetric flask, and make up to the mark with distilled water. And finally, you invert the flask a few times to ensure even mixing. Okay, so that pretty much covers the answer. Hopefully you found it reasonably useful, sort of roundup of not just what the answers are, but how to maybe construct your answer, how maybe to plan it out. So always remember the tips for doing levelled questions. So you need to read the whole question before you start, you need to plan your answer, and you need to address every part of the question to have a chance of getting 6 marks out of 6. So thanks for your time, thanks for listening, and see you soon.